Geothermal energy and volcanoes, unleashing nature's power. Geothermal energy and volcanoes, unleashing nature's power. Introduction. Nature has gifted us with an abundance of resources, and one such remarkable power lies within the Earth itself, geothermal energy. This source of renewable energy harnesses the immense heat generate by the planet's core. Volcanoes play a pivotal role in this process, acting as a gateway to unleash nature's power. In this article, we will delve into the fascinating world of geothermal energy. Understanding its connection to volcanoes, exploring its potential, and discussing its benefits and challenges. Understanding geothermal energy. Geothermal energy is derived from the constant heat emanating from the Earth's core. This process is fueled by the slow radioactive decay of minerals and the leftover heat from the formation of the planet billions of years ago. This incredible reservoir of energy has been utilized by humans for thousands of years, initially for bathing, and later for heating and electricity production. The connection to volcanoes. Volcanoes are magnificent natural phenomena that occur where tectonic plates meet and magma rises to the Earth's surface. The intense heat and pressure within volcanoes are crucial factors that make them a significant source of geothermal energy. Active volcanic regions around the world, known as geothermal hotspots, provide ideal conditions to tap into this vast energy source. Geothermal hotspots consist of subsurface reservoirs of hot water and steam. These reservoirs accumulate beneath the Earth's crust, where the molten rock, or magma, is relatively close to the surface. The proximity of the magma heats groundwater, creating hot springs and geysers. In regions with intense volcanic activity, such as the Pacific Ring of Fire, these hotspots are particularly abundant, making them prime locations for geothermal energy extraction. Harnessing geothermal energy. The process of harnessing geothermal energy involves drilling wells into the subsurface reservoirs. These wells allow the hot water and steam to rise to the surface, where they can be utilized for various purposes. The two primary methods used to extract geothermal energy are known as dry steam and flash steam. Dry steam plants tap into reservoirs with high-temperature steam, allowing it to flow directly through pipes to drive turbines that generate electricity. These plants are the simplest and oldest form of geothermal power plants but require specialized reservoir conditions. Flash steam plants, on the other hand, are more prevalent and widely used. They involve drilling wells into reservoirs with high-pressure hot water. As the hot water is brought to the surface, the pressure is greatly reduced, leading to flashing, or instantaneous evaporation of a portion of the water into steam. This steam then drives the turbines to produce electricity. Benefits of geothermal energy. 1. Renewable and sustainable. Geothermal energy is a renewable resource as it takes advantage of the Earth's continuous heat production. The supply is virtually inexhaustible, making it a sustainable source of power. 2. Low carbon emissions. Geothermal energy emits minimal greenhouse gases, making it an environmentally friendly alternative to fossil fuels. Its utilization can significantly reduce carbon dioxide emissions and contribute to mitigating climate change. 3. Baseload power. Geothermal power plants operate continuously, providing a stable and reliable source of electricity. Unlike solar or wind energy, geothermal energy can produce power consistently. irrespective of weather conditions. 4. Heat utilization. Geothermal energy is not only limited to electricity production. It can also provide direct heating for homes, industries, and greenhouse agriculture. This wide range of applications makes it a versatile energy source. Challenges and limitations. While geothermal energy holds immense potential, it also faces certain challenges and limitations that hinder its widespread adoption. 1. Location dependency. Geothermal energy extraction is geographically constrained. It requires specific geological conditions found in regions with volcanic activities, limiting its accessibility to certain areas of the world. 2. Initial investment costs. Building a geothermal power plant involves significant upfront costs, including drilling wells and installing infrastructure. The high initial investment can be a déterrant for countries or regions with limited financial resources. 3. Resource depletion and recharge. Prolonged and excessive extraction of geothermal energy from certain reservoirs may deplete them faster than they can replenish. Sustainable management and monitoring are necessary to prevent the overuse of this finite resource. 4. Geological risks. Drilling into subsurface reservoirs poses some geological risks, including potential earthquakes in already seismically active regions. Thorough geothermal exploration and careful well placement are essential to mitigate these risks. Geothermal energy, exploring its potential and overcoming challenges. Geothermal energy, fueled by the Earth's core heat, is an extraordinary resource that can be harnessed to meet our energy needs. Volcanoes, acting as gateways to this power, play a vital role in the process. In this article, we will further explore the world of geothermal energy, its connection to volcanic activity, its benefits, and the challenges it faces. An understanding of geothermal energy begins with recognizing its origin. It stems from the heat constantly radiating from the Earth's core, driven by radioactive decay and the residual energy from heat planet's formation billions of years ago. Humans have utilized this vast reserve of energy for centuries, initially for bathing and later for heating and generating electricity. Volcanoes are crucial in the geothermal energy process. They occur where tectonic plates meet and magma rises to the surface. The intense heat and pressure within volcanoes make them significant source of geothermal energy. Geothermal hotspots, found in active volcanic regions worldwide, offer ideal conditions for tapping into this immense energy source. Geothermal hotspots consist of subsurface reservoirs of hot water and steam. These reservoirs accumulate beneath the Earth's crust, where magma lies relatively close to the surface. The proximity of the magma heats groundwater, resulting in the formation of hot springs and geysers. Regions with high volcanic activity, such as the Pacific Ring of Fire, possess abundant hotspots, making them prime areas for geothermal energy extraction. The process of harnessing geothermal energy involves drilling wells into the subsurface reservoirs. These wells enable the hot water and steam to rise to the surface, where they can be utilized for various purposes. There are two primary methods of extracting geothermal energy: dry steam and flash steam. Dry steam plants tap into high-temperature steam reservoirs, channeling the steam directly through pipes to drive turbines for electricity generation. These plants are the simplest and oldest form of geothermal power plants, but they require specific reservoir conditions. Flash steam plants are more prevalent and widely used. They involve drilling wells into high-pressure hot water reservoirs. As the hot water reaches the surface, the pressure is rapidly reduced, RISU. Resulting in the instantaneous evaporation of some water into steam. This steam then powers turbines to produce electricity. The benefits of geothermal energy are numerous. Firstly, it is a renewable and sustainable resource, relying on the Earth's continuous heat production, which makes it a reliable source of power. Secondly, it emits minimal greenhouse gases, offering an environmentally friendly alternative to fossil fuels. By utilizing geothermal energy, we can significantly reduce carbon dioxide emissions and combat climate change. Thirdly, geothermal power plants provide a stable source of baseload power, operating continuously regardless of weather conditions, unlike solar or wind energy. Lastly, geothermal